All right, let's get going here. So this is our second video for today. This is over the metric system. So this is a recorded lesson over the metric system. What I need students to do is to watch the video here and then complete the notes on a Google form after they've done the notes. And you can do it at the same time if you can, but if not, then watch the video and then do the notes after. Okay. I've underlined things in the notes, and you'll see those questions in the Google form. And so a lot of it is just filling in the blanks. And then some of this we will be solving problems in this video, and so you'll answer some questions about that as well. All right. So we just need to follow along and complete our notes. All right. So first, let's talk about measurement. Measurement is a way to measure things around you. So it's kind of like if you've got a pencil, like how long is that pencil? So you can do length, you can do mass, so you can do weight, how heavy something is. Measurement is a way of giving something a number, right? And not just saying, okay, it's heavy, but how heavy is it, right? And so there's a difference between just relative, okay, this box is heavy and this box is light. When we say measurement, we want to give it a number, all right? And so there's always two parts of a measurement, and that one part is the number. We need some kind of a number to reflect how much or how big or how long, how small, right? And then we want a unit, okay? Units are a way to make everything have a reference. So if I say that a pencil is 10 inches long, that's a measurement, right? And that's a unit. The unit is inches. And so we know how big an inch is. And so that when you say that or write it down, someone else will kind of know how much that is, right? So that there's communication, right? So you can communicate how much that is. Same thing with the pound. We kind of have an idea of how big a pound is. So if you weigh something and you say, okay, it's 5 pounds, then we kind of know what that is, right? It's 5. But if you just say 5 by itself, 5 what? How do I use that information? So if you have the unit there, then you have the number and the unit, then you can communicate that weight with someone else. All right, there are two main systems that are used in the world. One of them is called the US or English system. The English system has things like the foot, the inch, the yard, Fahrenheit temperature for taking temperature. And then the other system is the metric system, and it's used by the rest of the world. All right. The metric system also has another name, and it's called the SI system, or System International in French. And this is a system that the world is kind of agreed on to set up units so that scientists can communicate their measurements with each other. Okay, so this table 1.1 has got some fundamental SI units or metric system units. So we'll talk about these in a second. Okay. So most countries in the world use the metric system. There's only 3 countries, including the US, that don't. All right, the metric system is a base 10 system. Therefore, it is compatible with scientific notation. So it's really nice. Okay, it's also used with our decimal system for numbers. Okay. The difference between one metric unit and the next is multiplying or dividing by 10, or moving the decimal place once, either to the right or to the left, whether you're multiplying or dividing. So if you move that decimal or multiply by 10, then you can get from one unit to the next. So that's why it's base 10. To get from one unit to the next, it's 10. There are 3 base units in the metric system. So when you're using the metric system, there are 3 main units that we will be using. Okay, so if you're measuring length or distance, you want to know how long a book is. You measure the length of a book. If you're using the metric system, you need to be using meters. So the base unit, the unit that we use for length in the metric system, is the meter, and the symbol for meter is little m. Okay. And then if you're going to measure mass or weight, so if you're going to figure out how heavy something is, we're going to use grams as the unit. And the symbol is G, little g. All right, if we're going to measure volume, which is how much space something takes up, like a liquid or a solid, if you're going to measure volume, especially of liquids, we're going to use the unit liter, like a 2-liter of Coke. If you know that, that's the metric system. Gallons is not. Gallons is the English system. So we will be using liters. which is actually capital L. Okay. All right, time is another unit that we will measure. So for measuring time, the unit for time that we will use is seconds. Keep in mind, though, that seconds is not base 10. All these other units is base 10. The meter, the gram, the liter, these are part of the metric system, the base units of the metric system, and they are base 10. Time is base 60. All right, there's 60 seconds in a minute. So just keep that in mind when you're dealing with time. And then here's a website down here that you can look at. It's the metric system website. So let me go ahead and show you what that looks like. And it's kind of neat. So it's got some history here about the United States trying to convert to the metric system and how that affected oil prices. So that's kind of interesting. And then it talks about the units. This is all of our prefixes, how to convert between units. It's got some examples. And so this is a pretty good website for, here's some practice problems. Pretty good website for the metric system. All right, so I gave you guys the link for that there at the bottom. So you just click on that link. All right, metric prefixes. So I'm going to be writing on here. Okay, so we need to know our metric prefixes, okay? So let's start with the, let's see. Let's talk about our base units. So the base units are the meter, which is M. All right, the liter for volume, and the gram, little g. These are our base units of our metric system. If I say 1 meter, what that means in scientific notation is 1 times 10 to the 0, or just 1. So it means 1 meter. And a meter, if you don't know, is about 3 feet. Okay, give you an idea of how long that is. A liter, 1 liter, is the same, 1 times 10 to the 0, which just means 1. Okay, so we start there. We start with 1, and then we have these prefixes, metric prefixes, that we add on, and we can make the number bigger. We can multiply by 10, and then 10, and then 10, and each time we multiply by 10, we get a new unit. Or we can divide by 10 and make things smaller. So that's how we can have like the meter, which is 3 feet, and then we have centimeters, which is a little less than an inch, right? All right, and then 1 gram is 1 times 10 to the 0. All right, so these are all times 10 to the 0. Okay, just depends on what you're measuring. If you're measuring distance, then we'll use a meter. If you're using volume, measuring volume, then we'll do a liter. And if we're measuring weight or mass, then we will be using grams, little g. Okay, so let's go ahead and take our meter. Here's 1 meter. Let's go ahead and say I want to multiply that by 10. What will we get? We will get a decameter, okay, which is not very heavily used, okay? And then let's multiply by 10 again. Let's take a decameter and multiply by 10. We will get a hectometer, which is also not used that much, okay? But then let's take that and multiply that by 10 again. And then we get a unit that is pretty heavily used in the metric system, and it's called a kilometer, okay? So if I take a meter and multiply it by 1,000, or 10 times 10 times 10, 10 raised to the power of 3, then I get 1 kilometer. Okay, so that's the symbol, km, and then this is the word, kilometer, kilometer. This is 1,000 meters. That's a very, very commonly used unit. The kilometer is used in Canada. It's used everywhere else in the world except for the United States, essentially. And so we have miles per hour on our speedometers and on our speed limit signs. They have kilometers per hour, which is different. Okay. And I've actually seen that myself personally. I've been to Germany when I was in college, and I remember seeing kilometers per hour on the speed limit signs. And I remember seeing speed limit signs that said 100 kilometers an hour. And I'm like, how fast is that? That seems kind of fast. But 100 kilometers an hour is kind of like 60 miles per hour. So it's about our same speed limit. So that was kind of interesting to see that and experience that. Also, as you guys know, Europe and the UK, they drive on the opposite side of the road, and that was very interesting. And the roads were very small in Germany, tiny, tiny little roads. All the trucks were all squished. Like you didn't have our giant semis. We had trucks to carry goods, but they were much smaller. So it's just different world. Kind of cool. All right, let's go the other way. So pretty much the kilometer is our main big unit, and it's 1,000 meters. Okay, so that's a conversion factor. 1,000 meters is 1 kilometer. That's our definition of a kilometer, 1,000 meters, or 1 times 10 to the 3. All right, let's take a meter and let's divide it. Let's take a meter and divide it by 10. Right? Remember, all we're doing in the metric system is either multiplying by groups of 10 or dividing by 10. So we're going to divide this by 10, and we will get a decimeter. Okay, which is not used that heavily. Let's take a decimeter, divide it by 10, and we get a centimeter. And obviously, you guys have heard of a centimeter, so we use this pretty heavily. So a centimeter is equal to 1 meter divided by 100, or 10 to the negative 2. Okay, so if I have a meter, if I have 1 meter, what I can do is I can take that decimal, right? Remember that the decimal's to the right? If I take that decimal and move it 2 places to the left and say 0.01, then I get my meter, or then I get my centimeter. So 0.01 meters is 1 centimeter. Okay. Or 100 centimeters is 1 meter. Okay. And let's go back to the kilometer and do the decimal trick. So if I take 1 meter and multiply by 1,000, take 1 meter, put my decimal there. Remember that, so we can say 1.0 meter, right? So if I have 1 meter and I need to get to kilometer, watch how I can do that. I can move the decimal place 3 places. 1, 2, 3, and then add zeros here, and we get 1,000. So 1,000 meters is 1 kilometer. But I wanted to show you guys that you can move the decimal 3 places to the right to get kilometers. Okay, let's divide a centimeter by 10 again. We get another unit that's pretty familiar, the millimeter. Okay, and a millimeter is 10 to the negative 3, because we divide by 10 3 times. Okay, remember when we divide, the exponent is negative. So there are 1,000 millimeters and 1 meter. Okay, so the millimeter is kind of the opposite of a kilometer, right? A kilometer is 1,000 meters, and then there are 1,000 millimeters in 1 meter. So these are kind of opposites. 10 to the 3, 10 to the negative 3. Okay. All right. And then there's another one. Let's take 1 meter and divide it by 1 million. All right. Or let's do 10 to the minus 6 meters. What is that? All right. So that is called a micrometer. And a micrometer looks like this. This is the symbol for it. It's kind of like a U with a long tail. All right, so that's a micrometer. And a micrometer is equal to 1 millionth of a meter. So 10 to the minus 6 meters. So if I had 1 meter and I needed to get to micrometer, it's 10 to the minus 6. And remember, when it's minus, we're going to go that way. When it's positive, we go that way. And so we're going to go this way. We're going to take this decimal and move it 6 times. 1, 2, 3, 4, 5, 6. And then we fill these guys in with zeros. So this is how many meters it is. So 1 micrometer is equal to 0.12345, 1, 2, 3, 4, 5, and then 1 meter. All right, so that's 1 millionth. Okay. And that's about as small as we go. Let me show you guys the chart of the metric system. I'm trying to show you here the main units. So let's review real quick. I know this is a lot. There is here's our base units. We have our meter. So remember, it's just 1. So it means 1, or 1 times 10 to the 0, which is 1. We got a liter, which is 1. We got a gram. Okay. If we take any of these units and multiply them by 1,000, we get a kilometer. 1,000 meters is a kilometer. 1,000 liters is a kiloliter. 1,000 grams is a kilogram. All right, and a kilogram is a very common unit too. 1,000 grams is a kilogram. Okay. If we take the meter and divide it by 10, we get a centimeter. A centimeter is equal to 1/100th, or 10 to the minus 2. So we can take this and divide it, move our decimal place 2 places over to get a centimeter. And then if we move our decimal place one more time, we get a millimeter, 10 to the minus 3. Okay, if we move our decimal place 6 times to the left, then we get a micrometer, which is 10 to the minus 6, okay, which is very tiny. Kind of getting towards, the size of an atom. An atom is smaller. I think an atom is about 10 times 10 to the minus 10, but micrometers are very tiny. Okay, so here is our units here. So here's 1 meter. Let me change the color here. So 1 meter, 10 to the 0, or just 1 meter. So right there. Let's multiply by 10. We get 10 meters, or a decameter. So deca is DA. And so this is kind of funny. A decameter, if you write it out the way that they did it, is it's DA and then M. So 1 decameter would be 1 dam. That's kind of funny. So that's 1 decameter. So that's interesting. Hectometer is H, and it's 100 meters. So 100 meters. So I move that decimal place. So notice that we start with 1. Watch what happens when I move my decimal place 1 time. Boom, we get 10. Decimal place is there. All right, so that's equal to 10. Let's take 10. Let's move our decimal place 1 more time. Add a 0. What do we get? 100. Boom. Multiply by 10. Move that decimal place 1 more time. Boom, 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 boom. And see how the decimal is at the end? We just keep moving that decimal further to the right. So these are big units. Move the decimal to the right. Positive exponents. All right, so this is 10 to the 1, 10 to the 2. And we're just multiplying by 10 over and over again. Okay, remember that the kilometer is a very common unit. Kilometer, kilogram, is 1,000 meters or 1,000 grams, right? Mega is a million. Giga is a billion. Tera is 10 to the 12th, and so on. And then let's go smaller. Let's take a meter and let's divide it. Let's take a meter and divide it by 10. Meaning let's take 1.0 meter and let's move our decimal place 1 place, put the decimal there, that's 0.1 meters, and we get a decimeter. Divide by 1 again, so 0.1, move the decimal place 1 more time, we get 0.01 meters, or a centimeter, right? That's 1 out of 100, right? That's the 10th place, that's the 100th place, 1 out of 100. All right, divided again, we get millimeter. Divided again, now to get from here to here, this is a jump of 3, 10 to the 3. So if we divide a millimeter by 1,000, then we get a micrometer. So there's a huge jump between these two. Notice that there's only 1 difference, but here there's 1,000 difference, right? 10 to the 3. It's 3 between 3 and 6, and so that's a micrometer, which is really tiny. If you keep going, you get nanometer, picometer, and so on. So this just has all the units, and you should keep it somewhere for reference. I will be giving you a copy of this in class if you're face-to-face, and I can make this document a document that I can share with my virtual kids. We can do that. Okay. Here's some units. This is kind of what we already did. The prefix goes before the number to indicate how large or small it is compared to the base unit. All right, and that's our base unit. So that's pretty much it. All right, thank you guys. Make sure that you guys complete the metric system notes, the Google form. All right, make sure you have your full name and class period on it. All right, thank you guys.